How many people were here during the kernel summit's trace point discussion? One, two, three, four, two. I talked about something, and I'm upset about myself because I made a mistake. I mentioned stable ABI, and that was the first thing I should not have done. I should never have said that. What I should have said, let me give it real quick way I should have brought this up. I'm going to give it to you guys. I should have been more educational. First of all, there's two different things. There's a trace point and trace event. A lot of people mix the two up or consider one's the same, or they'll say trace points when they really mean trace events, and they'll say trace events when they really mean trace points. They're two complete different mechanisms. A trace point is like a K probe or ftrace core. It's just a hook into some code that you can attach a callback to. Nothing more. That's it. In fact, Matthew was the one that introduced this. It was his code. It's in tracepoint.c, tracepoint.h. Those are the two files that you need for trace points. That's all it is. It's a mechanism. It's just, you put that out, when you look into the core kernel and you see trace underscore scan underscore switch, it passes three parameters, a preempt boolean, and two task pointers. And what you do with that is dependent on whatever you hook to it. The trace event is the stack on that. A trace event is usually used by tracing utility. ftrace has its own trace event stack. Perf has its own trace event stack. LTTNG has its own trace event stack. A trace event is really what defines what to do with that trace point. It creates the files. It creates that you see in the trace events directory. That's the trace event stack. Perf uses it. That's what Perf knows. What do you record from that schedule switch? I'm going to record the PID. I'm going to record the next PID and the priority and all that. That's all defined by a trace event. That's not That's not a trace point. So I could right now today write a module that connects to the schedule switch trace point that implements a trace event that does all deadline information on task switch. I can do that today without a problem and put it into a separate module and hook it. So this is the way I should have started the talk and never bring up stable ABI. In fact, today there's actually, I wrote a utility to find any orphan trace events. A trace event is a trace event stack that contains both perf trace event stack and the ftrace trace event stack that has no actual trace point attached to it, or that it uses. So basically, it shows up in your trace event file system, and you could say echo 1 to enable, and it does nothing. It's like that light switch without any wires hooked to it. You're like, what does this thing do? I have a light switch in my house that I've been going up and down checking every single thing, and I'm just like, it has wires that go somewhere into the wall, but I have no idea what it does.
Do you do it statically, or you do it at runtime?
The light switch?
Yeah, because it can depend on if-defs. And,
no. No, I do it at runtime, but also, no, it searches the runtime table, and then I do a trace search, and then I look at it. And a lot of these trace events, someone says, oh, I'm going to create a bunch of trace events, and I'm going to use them. And I searched, they never used them. Some of the trace events I found out that were existing, they had the code where they had the trace points attached to them was removed. They never removed the trace events associated to that code. So right now I'm doing a cleanup. So there are two different things. So that's doing that. So what we wanted to do was, there's a lot of places in the kernel that people don't want trace events. The scheduler folks said that, Peter Zilstra particularly said, I don't want any more trace events in the scheduler code because there's already utilities that depend on the information that those trace events give. And if I modify it, I break those utility, I break user space, and Linus yells at me. So I don't want to do that anymore. But we asked them, like, would you mind a trace point that no one cares about? That you have to attach to by either a module or eBPF program. And this is where I brought up the idea of, like, this could be a staging ground for stable ABIs, which is where I started my talk, which I should never have done it this way. Because this way, you put the trace points in, and then load a module or eBPF program that attaches to them to do something, defines what to do with those trace points. When those trace points disappear or get modified, the utility that you attach breaks. Now that's the question of, is that really a user space breakage, since you had to load a module or an eBPF program that knows the guts of the kernel. Just before my talk on Wednesday, I saw Linus and I ran up to him, and basically told him the differences between trace points and trace events, what I just kind of told you. And I said, you know, is it okay to add trace points? And he said, well, you already have trace points all over the kernel. I'm like, yeah, we do. But he's like, no. You have function tracing. You could get, because I don't believe that, he said, I believe you can get everything you need to know from the arguments of a function. I said, well, what happens if it gets inlined? Because if it gets inlined, you can't attach to it. He said, well, make it not inlined. So if you have a for add a function that, so basically we're modify code to make a trace point, we're going to just say, hey, call a function here. That will happen to be something that we could attach ftrace to. And this is where I want to kind of like just really understand what, so just to give you an idea of what ftrace does, and this is the old ftrace caller. I want to see if I have the new way of doing things. This is an old. Can I go back? This is still. Come on, where's the fentry? Fentry. Here we go. Inside the code, this is from a talk from a long time ago that I gave. The way fentry works is the fact that you have when you compile the kernel with -pg and add -m fentry, every function call that's not inline gets a call to fentry. At boot up, we turn them all into nulls. And then what happens is, when you want to trace a function, this is what I said earlier in my little 5-minute update, how we created trampolines. This is the trampoline that's actually dynamic trampolines. You create the, you patch the function call and calls ftrace caller, which jumps here, calls this guy who calls and calls some function over here. This could be a loop, it could be a specific function, whatever. We actually have code here to save registers. So when this gets called, you set a flag. If you don't care about registers, you don't set the flag, and it'll call just a function. It doesn't save the registers because that's actually expensive to save all the registers if you don't care about it. But kprobes uses ftrace, and it requires the registers because it wants it to look like a breakpoint. So breakpoints does a register save. So kprobes, when it registers to ftrace, it tells ftrace, hey, save registers before you call me. So it sets the flag, and when ftrace gets hit, it says, okay, save the registers and call this function. Once we do that, we have the registers, which means we have all the arguments. This is how live kernel patching works. It takes it, and also not only does it change the arguments, it changes the return code, return ID. So when ftrace comes back, it says, oh, we don't actually want to call this function. We want to call some other function. So it hijacks the function and jumps by sales. What Linus wants me to do is to build on top of this, have user space, take the dwarf information or whatever to figure out where to find information from the arguments or whatnot from the registers at this point to get the information you need. Write basically an infrastructure to make this easier, that it will either create eBPF programs that we can just easily create. There's a large learning curve to use eBPF. And it would be easier if we had some sort of functionality to maybe figure out, well, maybe inside the kernel we'll just implement give me arguments, and then have a way of just telling the kernel what arguments you want, and have something that could read the dwarf file from user space and pass the information easily into ftrace or whatever, and say, give me these arguments, and then also do the same for the function graph tracer, which has the return code. So you can say, not only can I attach this to the entry, I can attach it to the exit. And that way I have, and once I attach this, I would create a trace event. So the trace event stack would now be created by this infrastructure. So you could do triggers, you could do filtering, you could do all this other stuff. That's what I'm going to try working on. I mean, okay, now here's the discussion part. Am I crazy? Okay, based on this, not on anything else.
Yes.
Thoughts?
Well,
where's the mic?
one is coming. That's okay.
So what happens if some of the arguments get optimized out because
Optimized what?
optimized out because compilers do optimizations, and sometimes in GDB you see some argument on some local variable, you don't see a value, you see this was optimized out.
So basically,
if you had a trace,
the argument's not used, you don't care.
It might be that they are used, but the code is re-optimized in such a way that you cannot extract the initial value. And if I understand correctly, if you put a trace point in, it means it has to be there because eventually you want to extract it.
Right.
And if you don't have a trace point, there's no guarantee that
Now,
everything you want to extract will still be there.
what we could do is add something that may not be so upsetting by people, or by putting a trace point. Instead of putting a hook or anything, we could have just a trace args or some sort of stub that uses an assembly thing that passes the arguments. It uses the what's that called? I can't think of the term. The constraints. Uses the constraints of the ASM.
Yeah, that's the system tap SDT approach, right?
Right.
For
So
user
just
space.
put-
I mean, it's functionally the same thing as a trace point.
Except it has no code.
Why would we re-implement that?
It won't be. No, we just. It has no code. No, it has no up, no nothing. It's going to be a stub. Assembly.
It does need a no-up.
No, it doesn't.
Oh, okay, I was talking about the SDT approach.
Right. I'm saying is what I would say is you can have it by this function. If you need this function, if you need this variable, you can just put in a little ASM thing where you can have a little marker like say trace arg and pass in the arguments you want. And all that's going to do is pass them into an empty ASM command. So basically an ASM volatile quote, 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 nothing in there. And just passing constraints. That tells GCC that this assembly blob uses this, even though it doesn't do anything. So that means it won't optimize it out.
But Stephen, you care about function entry here, not within functions, right?
It could be both. If you put it in the function, then if you put that in the first thing of the function, then when it compiles, it will see that it's used within the function, so it won't optimize it out because it doesn't know what it's doing. So ideally, you put it within the function if you need to trace it. But then you can't optimize it out, which means that you're going to slow the machine down. Linus seemed to be okay about that. He did say, if I come through and implement all this, he's like, I threw it back at him. I said, okay, Linus, I'm throwing this back at you. If I go and implement all this stuff, and it's still not enough, can I do trace points? He said, show me 100 people that want it, I'll let you do it. How many people? 1, 2, 3.
But
I don't know if we have 100 people in here.
I get a different interpretation of what Linus said. It's mainly about, it's the IPI trace point, right? We were asking him if it would be okay to just add a trace point hook without exposing it to the user space. And my understanding of his reply on this is, if we can make a case and show that 100 people want the trace point hook, he's okay with it.
Well, no, but he did, yeah. Well, yes, he said, I want to see that, but he also said, see if you can do it this way first. Because that's what, you came at the end of the conversation.
And this way would be the hooking on function.
Yes, it's getting your information from the function. If you can't get the information from the function, then he'll look at letting you put the trace point in if there's a push for it.
Yeah.
So basically he said, try this first. If it doesn't work, I'll be open for that.
Yeah, I see two main issues with Linus's approach. The first is hooking on function, first of all, inlining. So he said, oh, just put them no inline. Right? That was his answer. So I cooked up a small patch. I have not been had time to run benchmark yet, but the idea is I'm trying to change all the existing kernel trace points into something that has a side effect to make the function that embeds them no inline. And that can actually be done by computed gotos. I'm not even using the computed goto, but I'm forcing the compiler not to inline the function. So I look forward to see what will be the numbers on the kernel.
Hey,
to go inline all the
way.
functions, right?
Just to let everyone know, the only reason why I basically threw this and said okay to Linus is because I've been wanting function tracing to do arguments for a long time, and now this actually gives me incentive to do it. But I'll build the infrastructure on top of it, and again, I shouldn't say I hope because I'm the one writing it. I'm going to try very hard to see if I can not do trace points. That's what I'm telling myself. See if I can get all the information I need without doing trace points. And if I fail at it, then we do trace points. That's my approach. I mean, basically, it's a way to get Linus to say yes.
There's a second thing. So currently, Linus is really into eBPF scripts and hooking onto functions and all that stuff. So, I mean, it's all fun as long as it's So we are not seeing a couple of years of release cycles of the Linux kernel, because in 2 to 5 years from now, we will have had code refactoring that will have changed those functions. And every one script they find on the internet are going to break. So people will complain. So I don't see any way around
No,
that.
actually, here, okay. Discussion part. Since I know it's getting tired at the end of the week, I've been here since I left last Thursday. I've been here since last Friday. I've been through several conferences. This is like my 7th or 8th presentation while I'm here, so I'm exhausted. I know I'm more exhausted than you guys are. I want to leave here too. So, I'm trying to wrap this up. Question. First of all, how many people would use function arguments to trace, just to be like, if I have the arguments of this guy without recompiling the kernel or touching it, just say, give me the arguments of this function. Hands that would use that? Couple? A few, maybe?
Kind of depends on how much impact it has.
But no, basically, it's like, no, believe it or not, you probably wouldn't even notice it at any benchmarks. I mean, I'm not saying all functions. I'm saying, give me these functions, which I have other things that ftrace will be doing, where you just say, hey, I want just trace all the functions in this file.
So that's what I can do with eBPF.
What's that?
So that's what I can do now with eBPF.
eBPF, can you do? No, not yet. But eBPF, you will be also eBPF will be hooked onto this. So you can actually attach eBPF on ftrace. It's sort of there. It's not quite there yet. But I don't know. There's some patches. I don't know if they were accepted yet. But I'm not sure if eBPF hooks to function trace points. This will be able to get all the information there. So there's a few people that said yes, they would want it or not. For those, would you write scripts? Who uses trace points here, or trace events? Should I say trace events? Who uses trace events? Quite a bit. How many people have scripts that depend on those trace events? One hand? Two?
Tons. I mean, yeah. So just one thing. Carrot Pro, we have been forced to use that for specific prototyping of network stack. And so we rely on Carrot Pro in LTTNG as a really last resort thing.
Yeah.
And they happen to break. I mean, over years, the code changed much more than trace points, and it's a pain to maintain.
Yeah. Well, I think we're all exhausted. Does anyone have any more you want to talk about this or anything else? This is open floor.
Just one question. So every time this comes up, the examples are always scheduling trace points or VFS trace point. So did you look at whether these kinds of trace point would be able to be done this way, like hooked on the function entry, or whether they should be somewhere inside of some function?
Well, actually, if I do it this way, if the function's already not inlined, they have no say. I can do it now. So this actually goes above the maintainer. I now basically can add full functionality to anywhere in the kernel that has an F entry in it. So I can trace their stuff. I can hook something to it. I get arguments. I get information on it. Latest said, if someone depends on your arguments of a function, then too bad if it breaks. He basically said that. So he's been he's starting to get around that. Maybe he should be so draconian with can't break user space. If you have user space that depends on the internals of the kernel, I think he's starting to say, okay, that's part of the kernel. That's the like a module. You can't have modules with KABI. You can't really have user space that basically finds. These are basically extensions of modules. eBPF to me is nothing more than a module. It's the Python module, where a module is C module. eBPF is more like Python, but it's still a module, although it's interpreted. So they're both executable inside the kernel. So any open floor discussions anyone would like to get up and talk about? Well, I think we're done for the week. I hope you had fun in Prague.
Yeah. Thank you, Stephen.
And thank you very much.
Thanks, everyone. So this is the last. This was the last segment of the Tracing Summit 2017. So thanks to everyone for being here. Have a nice trip back.
Yeah, extra half hour.
Yeah.